program on smart farming, application of AI, robotics, IoT, and cloud computing. Our today's topics are foundation of cloud and hand-on with Amazon Web Services, basic cloud operation. For that, we have with us Mr. Dhruv Rana, who is a senior software engineer, cloud computing, Amazon Web Services, DevOps. He is software professional with more than 5 years of experience in designing and developing software modules on Python and Java language. Sir has specialization on AWS infrastructure, designing highly available, scalable, performance efficient, and cost optimized solutions for the enterprise customers. He has been awarded with Academic Excellence Award and Employee of the Year. He has worked in the project in AD backend validation, process and project management, clinical trial survey, and network management system. He has an experience as senior system engineer in Wunderman Thompson Commerce, senior DevOps engineer in InfraStretch, and senior software engineer in Volances. With a huge respect, I welcome you, sir. Over to you, sir. Thank you.
Yes, thank you very much, Shraddha, for the introduction. So today I'm going to conduct a quick overview session on AWS Cloud, how this cloud infrastructure is going to benefit the agriculture industry, what are the applications, and how we can utilize the cloud platform to automate the overall process. So in the previous session, maybe Mr. Nikhil Shah have gone through the data science terminologies, the concepts for AI and ML. So data processing, analysis, then viewing the data which is processed is something which the digitalization is developed for. So in each and every industry, you can see like there is automation, there is digitalization. You have mobile applications, web portals, web applications going on. So at the back end, there would be some processing units. There would be some computing parts involved, and that's where cloud engineering will actually help us to provide those computing power, to provide those required CPU, memory, and hard disk. In each and every computer, even in a simple calculator machine, you have some computing power. You have specific RAM, you have specific processor, right? So to get these kind of requirement from the software perspective, when a developer designs and develops a specific software, this is really a critical phase. So from agriculture standpoint, if we talk about the applications of this digitalization, the platform which we have is tremendous. You have n number of applications. You can think of n number of ideas, n number of automation, n number of innovations, and you can collaborate it with the power of computing at the cloud platform. And especially when we talk about cloud, there are many cloud vendors available in the market, such as Amazon Web Services, Google Cloud Platform, Microsoft Azure, IBM, Alibaba Cloud, right? So these are the few of the vendors which the industry professionals are utilizing to host their computing instances, to host their networking requirement, to host their DNS routing and all these requirements. If we talk about specifically to AWS Cloud, we have more than 50% stakeholding in the cloud industry. So in the market, more than 50% cloud consumers are going for Amazon Web Services, and there's a reason why AWS is so mature. The community of AWS developers and these people who are actually using it for their commercial purpose is so mature and so enhanced these days. So after going through quite a bit brief on this topic, let's go through the presentation part. I have prepared a PPT and some of the visual data through which we can go through in an interactive way. I will try to make this session go two-way communication. So definitely, if you have something going on in your mind, just feel free to pop in your questions, queries, doubts, or any kind of ideas which I can take it as input and we can discuss over those things. So I think the possible ways are to unmute yourself, or else you can post it in the chat. So this is how we are going to address a few concerns or queries if you have. And taking that on the note, let's go through the PPT. Let me share my screen. I'm opening the presentation. Let me go to display. Yeah, now I'm ready to share my screen. Okay. So can anybody please confirm whether my screen is visible to you or not?
Yes, sir, it's visible.
Yes, sir.
Okay, fine. Yeah, that's great. Fine. So let's go through the topic which we are going to cover. It's really exciting. I bet you will go through a roller coaster ride today, because there are n number of services in. There are more than 150 services in AWS, and most of them are regarding computing, networking, storage, database. And then if we talk about monitoring, logging, right? If you are logging some data of agriculture, data metrics of, or else you are preparing some visual dashboards to present your data, to analyze it, to provide some metrics over it. For example, data from past 5 years, if you want to analyze those data, process it, filter it, and then you can get some useful information, because on that, based on that information, you are going to develop some model, right? And based on that model, you are going to develop your future projects, future ideas, future milestones, what you are going to achieve within the next 5 years, right? So going back in the past and collecting your data and processing it is really very much necessary. In case of agriculture industry, so far I have understood one thing, because it's not specific to agriculture, but definitely each and every industry is data oriented these days, because data is everything. Data is money, data is everything, because whatever information you get, you store somewhere, and based on that information, based on that data, you are going to nurture your project. So that's really a critical part of the overall ecosystem. And what else? Yes, as I said, like domain hosting services is also one of the common service which people use in the cloud services. And database, as I said, because storage and database are two different things. When I say storage, you can consider it as a Google Drive or maybe an Apple Cloud. Okay. And when I say about database, it's specifically to like an Excel sheet or MS Access or MySQL or MS SQL kind of database. So there's a slight, difference, a slight boundary between storage and database. Of course, database is a kind of storage, but it's in a structured way, or maybe it can be in a non-structured way, which can be considered as a NoSQL. So all these things we are going to cover in today's session in detail. So let me go to the very first slide of today's meeting. What is cloud computing? Okay, so there are basically two keywords here: cloud and computing. As I said, computing is nothing but just providing you some computing power, such as the CPU, memory, and the hard disk to store the data. For example, if you purchase a laptop system, then you get this kind of matrix. You get some processor, which is part of the CPU. You get some memory, which is a RAM memory, maybe 8, 16 GB or whatever it would be. And then you get some persistent storage, which is a hard disk or maybe SSD or maybe SATA, right? So these kind of three combinations is what it makes a computing unit. So computing means to compute anything which has the capability to process some data, which has the capability to write a code and then execute that code on that machine. Because most of the things we are going to automate, right? So what do you mean by automation? You are going to write some scripts, you are going to write some code, and that code is going to evaluate your data. and that code is going to process something, right? So in order to let that code process something, it will need some computing power, right? And that's what cloud computing will provide us. So cloud is nothing but just a virtualization of the machine, because previously, when cloud computing was not there, before that, people were mostly going for on-premises data services, or maybe some domain providers like Hostinger, GoDaddy, Cloudflare. So these are the very famous one which are still being used. But yeah, regarding cloud, it is really very much an enhanced version of it as of now as compared to last 5-6 years, because there are a lot more you know just a minute. Yeah, there is one query going on. Let me address this one. Does students hire the AWS space for the data manipulation without using having credit card, because students mostly don't have credit card? Any alternative from AWS? There is one alternative, but still in that case, at least one user needs to have that credit card, debit card information. What we can do, we can actually create one account, a single account, and that account can be associated with your credit card for the transaction and billing purpose. And from that account, you can create multiple users, right? So your students will be considered as a one IAM user. So single account with multiple users. So only one user have to attach those credit card informations, and rest of the students can use that account as an end user. And that user may have access to specific services, because in the cloud, especially in AWS, we have many services, more than 150 services. So the administrator who is giving access to the IAM user should have understanding like what level of access, read, write, full access, delete access, what level of access that user is requiring for, what level of access that student user needs. So the admin user needs to structure those kind of access requirement, and then provide only those specific least minimum access to the IAM user. Okay, and that IAM user is nothing but just a kind of student who is going to utilize that user account. So this is one possible way how we can make a workaround. And apart from that, like talking more about the cloud computing part, we have basically 2 to 3 characteristics here of any cloud computing platform, such as AWS, GCP, Azure, IBM Cloud, Oracle Clouds, anything. It is going to be remotely hosted. You are not going to get the physical access. So whatever servers or services you purchase on the cloud computing, you are not going to have the physical access, right? For example, if you host one server on US West 1 region from India, you can do that, but that's going to be a remotely operation. That's going to be a remote operation, right? So you're not going to have the physical access, but still you can access your machines. You can still access your servers, right? So that's going to be a remote connectivity. And for the remote connection, you can use protocols such as SSH, which is a secure shell, which works on 22 port number. Okay. So this is how you can actually access through your remote servers, which you have hosted on the cloud. Because definitely hosting a server means you wanted to perform some scripts executions on the server. You want to configure that server. You want to modify some config files, some configurations on the server. So that's where you will actually need access of the server, which is remotely hosted, and that's possible via 4 to 5 ways. Okay, so those ways we are going to cover practically in this session as well, which is going to be a part of hands-on session later on. Ubiquitous, what do you mean by ubiquitous? So it's going to be a services or data which is accessible from anywhere across the globe. So something which is available throughout the globe, from any part of the globe, you can access this kind of servers, you can access these services. For example, data stored on cloud is accessible from any part of the globe, even when you are geographically present from India or any other country. So that's where you are going to benefit. Like it's just like Google Drive. You can access your data from anywhere. So that's the a a good part of cloud computing, which is accessible from anywhere. Commodified. The result is a utility computing model similar to the traditional way. Like gas, electricity, you pay for what you use, right? So it is totally dependent upon your requirement. For example, you have a requirement of a server with 2 GB RAM, 1 CPU, and 10 GB hard disk. Okay, 2 GB RAM, 1 CPU, and 10 GB hard disk. Then you can select your instance type in the EC2 service. EC2 service in AWS Cloud is for computing. So here, if you have such requirement of computing for 2 GB RAM, 1 CPU, and 10 GB hard disk, then you can select your specific matching instance type on EC2 service. And that's where you are going to only get charged for what you choose. So based on the instance type you selected, you are going to be charged. So it's totally customizable. It's totally customer oriented. So whatever you want you will get, and based on your requirement what you select, based on that you will going to be charged for it. And basically there are two flavors here in the cloud computing these days, which is very much trending, which is serverless and server oriented. Okay, serverless and server oriented. So what are those differences? What do you mean by serverless and what do you mean by server oriented is what we are going to cover here. But from the high level, I can explain you some common differences between these two architecture, which is serverless and server oriented, because I have practically implemented this architecture in the industry as well, in a few of our customer projects, where serverless is something which you are going to be charged for what you use. For example, if you use this 2 GB RAM, 1 CPU, and 10 GB hard disk for only 5 minutes, then you are going to charge for only the amount of memory, the amount of processor, the amount of hard disk used for only that particular 5 minutes. Okay, so you are not going to charge more than that. But in case of server oriented, what happens actually, even if you don't use or you actually use it, you are going to be charged for what you chose. You chose 2 GB RAM, 1 CPU, and 10 GB hard disk. So even if you don't use it, actually you are still going to be charged for that computing resources, right? That's what server oriented is meant for, because once you choose your configurations, your billing is going to be initiated straight away. It won't actually matter even if you actually use it or not. It will just going to be initiated. The billing process is just going to be initiated straight away after you create those computer resources. So that's the major difference between serverless and server oriented. And these are really trending topics in the market, which is really uh, dependent upon the customer requirement, because in case of a startup company who is just going to be a prospective commercialized version of an enterprise, in those conditions, those people who are struggling with the budgets, or maybe a fresher, maybe a startup company, they go for serverless because it's going to be cheaper, right? It's going to be economic. So that's where serverless and server oriented architectures are mainly uh, varying in number of factors, because it's not just all about the financials, it's also about the performance. Because in case of serverless there may be some performance issues, but in case of server oriented architecture, the performance is going to be the key factor, because that's because the computer resources which you chose is going to be available till the time when you actually switch off those resources. Unless until you terminate those resources are going to be there for you. So that's where the performance, resilience, and these kind of factors comes into the picture when you talk about serverless and server-oriented architecture. Okay, so that's an overview about cloud computing, and here we are going to cover a lot more in detail. So till now, is there any doubt, query, or any questions so far? If yes, we can wait for 1 minute, and you guys can ping me in the chat box if you have any questions. It is 10:23 as of now here in IST, so we can wait for 10:24. Till the time, you can feel free to ping me.
Mr. Dhruv, we do not have right now any question. Would you like to take the question in between your session or at the end of your session?
Yeah, we can have at regular intervals, because what happens is people actually may get busy in some other task, and
True.
Yeah, so it's better like
I agree.
Get it conducted in regular time frame.
Yeah, you want it interactive. What we can do is we can put the question from the YouTube chat box to this Zoom room, and whenever question will be there, it will be reflected in the Zoom room also, so you can answer based on that. Right now we have only one question which I have already posted in this.
Okay, no worries, fine. So let's continue with this session.
Yeah.
As you can see, like many companies are delivering services from the cloud. Some of the notable examples are in front of you. The industry giant such as Google, Microsoft, Salesforce, all of these product-based companies, which are really industry-leading digital platforms, have already started since a decade. I guess since a decade they have started the use of cloud computing, because they have understood what is the key difference between the cloud services and the on-premise data centers. Because hosting in a data center for your personal need is going to be quite a bit cost effective, and the cost factor is going to be really something which is a part of worry when it grows. So for example, if your data is as of now 10 MB, when it grows up to 100 MB, 1 GB, 10 GB, then your cost factor will definitely come into the picture, because over the period of time you need to think about scalability, you need to think about cost optimization, and that's where cloud computing will provide you some cost effective solutions. So these are the basic factors which anybody should consider while designing any solution on the cloud platform. What are the benefits? You get n number of benefits. You can have a remote access, you can have ubiquitous behavior, you can access it from anywhere across the globe. It's going to be consistent, it's going to be secured. It depends upon how you configure, because security is also something which these days is a industry best practice. So security wise also it should be strengthened enough so that any intruder won't get access of your critical data, and any malfunction doesn't happen to your system. That's the reason why you to enforce security in your ecosystem, which is built on the cloud platform. So there are a few features, there are a few services available in the cloud platform, especially in AWS, from where you can configure the security periphery, from where you can strengthen your security. There are types of security layers, there are types of security mechanisms which you can implement in your architecture to leverage these security principles. Okay, fine. Let's move on to the next one. So talking about the basics, there are certain services and models working behind the scene, which makes the cloud computing feasible and accessible for the end user. For example, if you are the developer, you are developing some agriculture industry related application which will help you to collect the data from the sensors. For example, you are conducting a soil quality survey, right? You are going through various geographical regions using a drone. So that machine is going to have some sensors. It's going to have some camera. Okay, so that devices are going to capture those data. Their devices are going to collect those data and upload it to the cloud platform using internet connectivity. So that's where, a developer needs to develop a backend server, needs to develop a whole architecture over the cloud platform, and that's where, these are the basic services. As a developer, when you develop such architecture and implement it on the cloud infra, you will need these kind of basic concepts clear, because that's where you are going to perform your activities all the day through. So when you talk about the basics, it's going to be specifically two kind of models: deployment model and service model. What do you mean by deployment? When you say deployment, it's going to be, a simple process. For example, you write some code, okay, to develop a feature. You write some code, you build that code, and then you actually deploy that code onto the cloud platform, because ultimately your code is going to run on the cloud platform. So there are three basic steps: you write your code, you build your code, and then you deploy that build code on the cloud platform. So these are the three steps involved in the overall software development life cycle. And definitely, once you deploy that code, you are going to test it. For example, if you write a code to provide a mathematical calculator which has addition, subtraction, multiplication, division, modulo, and all these kind of features, then you're going to test it. For example, you test it negatively or positively. You pass two values, -3 plus 4, then it should be 1. So under any scenario, you can have some test cases, and you can test that developed software which is deployed on the cloud, to make sure the end user, when you use that software, doesn't face any difficulty. So the overall end user customer experience should be smooth. It shouldn't be something which is out of your expectations. So you need to thoroughly test your software once that software has been deployed on the cloud. So even after deployment, you have to test your softwares, so that actually when you launch your softwares onto the production environment, it doesn't go into any bizarre situations. Okay. And the second is the service model. So when you say service, a service model is simply, a self-hosted service in which you don't have to write any code, in which you don't have to build anything, in which you don't have to deploy anything. So all these three steps, which is write code, build code, and deploy code, will be eliminated. You can directly get what you need. For example, if you want to develop a notification software, so as soon as your sensor collects some data, it will push some notification on your registered mobile number that yes, this data is been collected. So that kind of notification service you need to develop, right? For sending that SMS on your registered mobile number. So that SNS service is already available in the AWS, which is known as software as a service, which is known as software as a service. So software is already developed for you for notifying anything. You just need to provide input, what kind of message you need to send and whom to send. So the mobile number and the message, just two things in the input, and your job is done. The software is already written and deployed on the cloud. It will accept those two inputs and send SMS on that registered mobile number. It's as easy as that. So there are two types of models. Deployment, as I said, like you to first write your code, build your code, and then deploy it on a cloud. But in case of service-based models, you don't need to write, you don't need to build, you don't need to deploy. It's just going to be consuming those software services, which is known as software as a services. So a few of the typical examples of software as a service are SNS, which is simple notification service in AWS. The other one is SQS, which is queuing, simple queue service. For example, what do you mean by queue? Queue is something of you. If you stand in a movie ticket ordering queue, it's actually a queue, right? The person who is entering in that queue first will get the ticket first. It's going to be FIFO model, first in, first out, right? So the movie ticket ordering system, who are and it gets in first, gets out first. So that's how the queuing mechanism actually work. And for that specific requirement, AWS has already developed SQS, which is software as a service. So that's where most of these services are developed, keeping in mind where what are the common applications, what are the common requirements like queuing, notifications, emails, and all these things, right? So for this specific requirement, AWS has already developed something for you where you don't need to write any code. You just need to provide some input and you can get the outputs of your desired expectations. That's it. So the next part is the deployment. Okay. In case of deployment models, you have four main sections, four main chunks of data, where you have private, public, community, and hybrid. These four kind of access are possible. And each of the section stands for specific usage. For example, if you want to keep your data totally private, you don't want to expose it. Okay. And in those scenarios, you can go for private hosted cloud services, in which those data which is being processed, those data which is been collected in the cloud will not get any exposure to the public access. And the privately hosted data is definitely going to be secured. So security wise, private hosted cloud services are going to be the most secure service, because nobody is going to have access except your private members. And apart from that, you also get a community version. So it is across the organizations. For example, you choose XYZ companies, so all those companies will get access to the specific cloud. So only those organizations who has access to your cloud services will get access to your community cloud services. And when you say public, it's actually going to be public, so anybody across the world can access your services. So keeping public is simply mean like you have exposure data across the internet, so anybody from any corner of the world can have access of it. So it is very much vulnerable, so it is not recommended by AWS as well to keep it public, because most of the intruders are in search for such publicly accessible systems. So keeping it public is really vulnerable, so you need to take care of that on yourself. It's a risk from your side, because AWS doesn't guarantee for any data loss if you keep it public. And the fourth one is hybrid. So the deployment model is going to be hybrid, where it's a combination of private plus cloud, private plus public. So if you want to keep some part of your data as public and some part of your data as private, then you can use such combination of services, in which half of the resources are going to be publicly accessible and half of the services are going to be private, totally private. So when you have some hybrid requirement to club both the things together, then you can go for a hybrid mechanism. Is it necessary that for these technologies one should be have through thorough knowledge of computer softwares? It is not necessary that only computer science students can have a good grip on this, but definitely these days many inter-domain engineering principles and disciplines are utilizing these technologies based on that applications. So based on your requirement, you can utilize it. There are n number of tutorials, there are n number of documentations available on the official AWS website. So I think even somebody if having a basic understanding of coding, for example a Python coding, then it's really straightforward for those people to just go on surfing on internet, search what you need, and then what you get is really one-stop solution. So you can get each and every step-wise document, what to do, how to do, along with video tutorials on the net. And that's what really makes it easy for the end user to configure, to set up your software on the cloud infra, because AWS Cloud is user friendly. You can go to the AWS console and exactly understand what is required, how is that going to be configured. You can get step by detail as well, so it becomes really easy. There's one more query. Is there any charge to migrate from one deployment model to the other? Yes, definitely. Because so once you configure and set up your infrastructure as a private, and then if you want to go to the public, then migrating your solution will also require some transfer services. So transferring your data, transferring your processing units is going to be something of a charge. But in case of public to private, it's going to be much more costlier, because making your computing part, database part, networking part private will require some more additional cost. So making it private is going to be always a cost intensive as compared to public, right? If you keep it public, it will be a bit lesser in cost. But in case of public, but in case of private, it's going to be much more costlier. And if you go for hybrid model, it's going to be, a combination of both. It depends upon which requirement you have. So I hope that addresses your concern.
Yeah, I do agree with you, Mr. Dhruv. And about that computer knowledge and software, if someone doesn't have any idea, but they anyway have to dive into this coding part and this Python software part. Otherwise, I think cloud or anything related to IoT would not work if you want to go ahead in the future. So they need to
Definitely.
have some idea on computer application.
Yes, yes, exactly, Dr. Priti, you are absolutely right here, because Python is really quite a bit easy to understand. It is totally descriptive language, so once you learn it, you will definitely get good grip on cloud computing and these concepts. Because when you execute your program on your local machine, you will actually get an idea of what is required, how you can process those data, how you can actually format it, how you can actually execute your code on your local. Similarly, same infra will be provided on the cloud. So there's a simple linkage between the local and the cloud. So once you actually try and work around those principles on local, you will definitely get a good grip on the cloud as well, because it's going to be ultimately the same thing. So you can have such kind of advantage if you practice on a local first and then go for the cloud. Okay, fine. Moving further. The service model is going to be three flavors here, as I discussed previously. A software as a service is one of them, and we also gone through a few of the examples like SNS and SQS. Depending upon that, we have two other flavors here, like infrastructure as a service and platform as a service. So a way to understand it from scratch, it starts from IaaS, which is AS, PaaS, which is PaaS, and SaaS, which is SaaS. AS, PaaS, and SaaS. Okay. So infrastructure as a service is nothing but you are paying for each and everything. You are responsible for each and everything, right from your computing resources, writing your code on that computing resources, and then deploying it, building it, whatever you need, you have to do it from your scratch. Okay. So infrastructure means the computing part, the software requirement. For example, if you write a Python script, you need to install the Python packages, right? It will require some libraries, it will require some dependencies, right? So first of all, you need to purchase a server on the cloud and then install your Python packages on the server in order to execute your Python script on that server, right? So there are 2 to 3 steps involved here. First of all, creating your server, then installing your Python dependencies because you want to execute your Python script on the server, right? So installing those dependencies is the second part. Then the third part is to transfer your Python script from a local to the server, so that the same script can be executed on the server as well, where your Python packages are installed. And then very last part is actually executing your Python script on the server, so that your code comes into the execution part. So as soon as you suffice these 3 to 4 steps, you are going to go live. So then you can have your Python scripts executing on the server, which is residing on the cloud, AWS Cloud. So that's what infrastructure as a service is meant for. You to configure it from scratch, right from the server to executing your code. But in case of platform as a service, you already get the required platform. For example, if you want to execute a Python script, you will get a ready-made Python server where you don't need to install your Python packages. It is already pre-installed. So when I say platform, it is like it will already be there, which is required to execute your code. If you want to execute the Python code, if you want to execute your Java code, all those dependent libraries will be already available in the platform. In general, for education and research, mostly computing licensing is under academic edition. Yes, Dr. Preeti. In general, for education and research, mostly computing licenses is under academic edition. In case of AWS, what I will suggest is like you can have a free tier services, which will not cost you something. So if you choose for free tier services, for example, for hosting your server, you have some free tier services for EC2. Okay, so EC2 is a service on AWS where you can host your server. So also in EC2 you get free tier services, which will come under such kind of R&D or maybe academic purpose. So that's where you can utilize AWS services in free tier without costing you something significant. So that's where you can utilize it using free tier services. Let me just you can use free tier services for academic and
Mr. Dhruv, this question is from one audience,
okay.
which is actually writing this message in the YouTube chat box, and you can reply by saying those things. And if you want to reply by chat, then I have to paste it on the YouTube again. So don't go for messaging. You just reply by yourself. They can listen.
Okay, that's fine. No worries. So verbal answering is also, I guess.
Yeah, that is perfectly fine. They can listen.
Okay, fine. No worries. If that is YouTube, then transcripts would also available, so that can actually go through those transcripts as well. Moving the next topic, which is software service. As I said, in platform as service, you actually need to write your code and then deploy on the pre-installed platform. As I said, like if you want to execute your Python script, then you can have some ready-made Python libraries on your server, which will be provided as a platform. But in case of software, you don't need to write anything. You don't need to even write your code. Whatever you have as a requirement, you already get it as a software. So that's where software as a service is the the most user-friendly service, where you actually just it's as easy as that you go on Amazon website, amazon.in or amazon.com, and choose whatever you need from the product menu. You pay for it, and that's it. You are done. Your order is placed. So it's as easy as that. In case of software as a service, you just need to search for which service you are looking for. If you get it, you can just subscribe it. That's it. You are done. So software as a service is simply subscribing to a specific service and you get those services. But in case of infra and platform, you need to at least write your code for your requirements. So that's the basic difference between us PaaS, and SaaS. And moving further, like these are the cloud service models. As I said, IaaS, SaaS, and PaaS. IaaS is the most complex part of it, because that's where uh, you need to have network architects, you need to have IT administrator who can actually administrate your servers. Otherwise your servers will not behave properly if any software package gets deprecated. So those part of maintenance activity, administrator activities are required in infrastructure as a service. But in case of a platform as a service, you don't require such maintenance or upgradation activities, because it's already part of AWS responsibility. So if you go for platform as a service, you just need to write your code and deploy it. That's it. So that's where only software developers will be interacting with it. And if you talk about software as a service, you even don't need to be a software developer. You can just use it as an end user. You can just subscribe the service and use it as you want. So some of the examples are Gmail, Trello, Slack, Office 365, which is really one of a good tool to prepare your slides, prepare Excel sheets, spreadsheets, and all those things. Just a minute.
Sir, you are muted. Hello?
Yes, I wasn't speaking. I just unmuted myself. I was just typing a message. Okay, fine. We can continue session. Let's move on to the next slide. So I hope you got a gist of what is infrastructure service, platform service, and software service. Now talking about AWS, because now we are going to be specific to the cloud platform, which is our Amazon Web Services. As a cloud provider, what it provides us to go for AWS and not some other cloud vendors such as GCP, Azure, IBM, or Oracle clouds. So in case of AWS, you get free credits. So when you say free credits, it will provide you some additional cost optimizations. It will provide, as a student, you can leverage those cost credits for waiving off your expenditure on the cloud. For example, if you use $100 worth of computing resources, if you have $100 credits, then you can waive off that costing, and that credits can be achieved by attending the AWS webinars. If you attend the webinars which is conducted by AWS, you get some credits into your account, into your registered AWS account. So that's a way how you can get some free credits to go and practice on AWS. You can go through some R&D activities as well. And definitely AWS will provide you servers, services on demand as you need. It will be auto scaled, so whatever the demand would be, AWS will take care of it. And As far as the scalability is concerned, it is totally scalable solution. So even if you need 10 GB or 1000 GB, whatever you need, you can get it on scale. And there has been a great revolution since AWS has entered the IT industry over the period of time, because definitely many of the applications I have seen in last 5 years is been migrated from on-premises to AWS Cloud, or maybe some other cloud like GCP or Azure. The main motive behind it is like you don't want to take care of the physical servers, those bare metal machines, because the maintenance activity is going to cost you something, and that's going to be a headache for you for a long period of time. But in case of cloud services, that's going to be a responsibility of the cloud vendor who is providing that cloud service. So you don't need to bother about those maintenance, upgradation, patch activities. You just need to use those services. That's the beauty of the cloud platform. And especially if you talk about AWS, you also get all those services, and you can just plug in and play. So AWS powers some of the biggest websites in the world, such as Amazon.com, as you already been using it, and Netflix as well. So Netflix is again a great platform which is mature, developed, enhanced enough to suffice the commercial needs. It is also streaming some data, it is hosting some data, it is providing some video streaming, audio streaming. So all of these applications are being provided at scale. So you you have rarely observed some performance issues in these websites. So it is so highly reliable, and that's where the AWS has its benchmark set. Like whatever service we provide, it has a specific benchmark. So it guarantees you for all the service level agreements you sign, and all those terms and conditions are clearly mentioned at the time of creating an account. So what are your responsibilities as a end user, what are their responsibilities as a cloud service provider? It is clearly mentioned in the terms and conditions clause. So you need to go through it very wisely, so you can get exact understanding of what you are responsible for and what AWS is responsible for. Okay. And further on, moving to the next slide, we are going to cover these basic services which are going to be a part of the hands-on session very soon. So providing you a brief about this services. EC2, as you know, like we have already called the services more than 4 or 5 times in the session today. So EC2 stands for Elastic Compute Cloud. So as you may get some glimpse of it from the name itself, Compute Cloud, it means computing part. So wherever you have some computing requirements, you should go for EC2 service, which is Amazon EC2. Here we have one more query from Dr. Preeti. Rather using a credit card, do I purchase the license on prepaid mode for access, provided I won't be deducted any further amount on exhaustion of my validity? Does it mandate to have credit card? Yes, this is something mandatory. You need to have credit card. You need to at least create one account using that credit card information, and then you can utilize that single account, as I said previously, to create multiple sub accounts, to create multiple users for your students. So that's where you can create those accounts using that specific credit card information. Only one credit card for all your needs. You don't need to create multiple accounts using your multiple credit cards for multiple users. Just one credit card, one account, and then same account can be used for multiple users. So that's how you can utilize your AWS resources wisely. Even if you have only single point of transaction as a credit card, you can manage all those users wisely. And from costing perspective, in order to get some notifications if it goes beyond some limits, For example, if you have something in your mind like my billing shouldn't go beyond $100 per month, then you can set billing alarms as well. In CloudWatch, there is a service called alarms, and alarms bit means it will actually alarm you under specific conditions, and here our condition would be billing. So if the billing goes beyond 100 USD is what your expectations for. So if it goes beyond 100 USD, it will shoot an alarm. And as well as it goes in the alarming situation, you can integrate some notification mechanism. So as soon as the billing goes beyond a specific amount, it will shoot an email. It will shoot an SMS. Okay, it will notify you something. So based on those notifications, you can get an exact idea. Yeah, yes, it is going beyond my expectations. So you can directly go into some action mode. You can cut down your resources. You can optimize the cost. So using those kind of mechanism, you can definitely get an overview of it, and you can get a prompt reply. You can actually act proactively. So fine, moving further. Apart from EC2, you also get ECS, which is a container registry, because these days people are mostly lenient towards Dockerization. So Docker is nothing but a container service. So if you want to host your Docker images, you need some container service, and that's for what ECS provides you. And if you talk about Lambda, it is serverless architecture, basically, which I explained in the beginning of the session. So serverless, it means pay what you use. So whatever amount of resources you use, only for those used instances, only what that specific used amount of memory and CPU you are going to be charged. So Lambda is one of those serverless service for computing part. So for computing solutions, you can go for AWS Lambda if you have any serverless requirement. And in case of S3, it is a kind of a Google Drive storage, which is simple storage service. S3 stands for simple storage service. So S3 is simply, a storage mechanism, just like Google Drive, where you can upload your media files, you can upload your documents in a structured way. For example, a specific folder would have media files, a specific folder would have your documents, a specific folder would have your spreadsheets, a specific folder will have your PPT and documents. So that's where you can organize your data and store it on the cloud. If you talk about RDS, it is a relational database service which can be used for MySQL, Oracle database, MS SQL, Postgres, these kind of relational database systems. Okay, and DynamoDB is going to be a NoSQL kind of database, so where you don't have any structure defined. So those kind of unstructured data can be stored in DynamoDB, which is a NoSQL kind of database. And NoSQL, what do I mean by NoSQL? It is going to be an unstructured form of data. It can be a PPT, it can be a PDF, it can be a JPG or PNG file. So any such kind of unstructured data is going to be for the DynamoDB service. And Elastic Cache. Elastic Cache is basically a service which is used for caching. So for understanding for using this service, you need to have a good understanding of what is caching. Caching is a process which occurs on the RAM memory instead of your hard disk. So instead of the persistent volume, you can process your data on the RAM memory, which will be performance optimized. You can get good amount of performance, but at the same time, RAM memory is cost intensive, so it will cost you heavily as compared to the processing on the hard disk. So if you want performance as a key metrics, then you can go for caching. But if you don't want performance, but if you just want the computing part, then you can go for hard disk, which is again RDS and these kind of database services. So Here, in case of Elasticache, we get two kind of flavors, which is Redis and Memcached. So these are two engines, two types of engines available in Elasticache, Redis and Memcached. So there are a few difference between these two Elasticache engines as well, but we can go in detail in the further sessions whenever and wherever required. The next service, the last service is IAM. IAM stands for Identity and Access Management. From the name itself, we can actually get a good understanding of it. Identity and access management. For example, if you want to create multiple users from the same account with specific access, with specific read, write, modify, delete, or whatever access you want to provide, you can provide it based on specific services. For example, if you want to give access only for EC2, only for Lambda, only for S3 bucket, and that too specifically read and write access, then you can create a new user in IAM. Okay, so IAM is a service which can be utilized to create more users, that too with specific service level access, so that those users would not have access to anything else in the cloud. So you can actually manage your access and provide some users. You can actually create a group of users as well. Just like in WhatsApp, you have a group of users. Similarly, you can create a group of users in your AWS account using IAM service. So all of these services we are going to cover practically as well in the AWS console. And moving on further, navigating to the AWS, we will definitely navigate to the AWS console and get a good understanding of how it looks like, what is required, what is not required in the session later on. Getting started with AWS. So, before we go through the AWS console and these things, let's consider going through the history of AWS Cloud. It was started in 2002. So it was internally launched previously, and then it just went through and through from 2002 till 2022. It's really a tremendous journey to keep on enhancing your performance, to keep on enhancing your overall experience for the end users. So it has added more and more services each year consistently for the software applications. So also in the agriculture industry, they have a few use cases and a few documentations available in the official AWS website, where you can go through how agriculture industry has benefited with the use of AWS Cloud. So this is a timeline overview how it has developed and evolved over the period of time. Now moving on further, these are a few of the facts about AWS Cloud. Like in 2021, AWS had over 50 billion in annual revenue. So you can anticipate where other cloud vendors are standing and where AWS is as of now. That's where the industry leader AWS is known for. So AWS accounts for more than 40% of the market share in 2021. So when you say 40% or more, it's really a good amount of stakeholding in the market. And definitely AWS is a pioneer and leader of the AWS cloud market for the 9th consecutive year. So that's where, and that's why people go for AWS, because it's really matured platform. It has a good amount of the community members who can come in and help you if you're stuck anywhere. You can get a good amount of documentation. You can have a good amount of troubleshooting of activities going on the Stack Overflow or on the official Amazon blog spots. So that really helps you a lot when you're stuck anywhere. And as you can see, like there are over 1 million active users who are actually interacting with AWS Cloud on enterprise level and actually using it for R&D or maybe in that actual implementation purpose. And these are few of the use cases which AWS has provided as a data point where you can actually get a good understanding for which users are actually are engaged on AWS Cloud platform and how they're using it. So AWS enables you to build sophisticated, scalable applications for any specific industry application, whether it can be automobile, agriculture, medical, education sector, or telecom industry, or whatever it would be. AWS is just one-stop solution for all your digital need. Whatever you need, you can get it from AWS platform as a single-stop solution, and applicable to a diverse set of industry. As I said, use cases include like enterprise IT, backup and storage, big data analytics, AI, ML, right? All these things like web hosting, gaming, mobile and social apps. You can host your mobile applications as well. You can build your application. You can deploy your applications. All of these requirements are included in the AWS package. So it has more than 120, 150 services from where you can go through and pick up the one which is of your interest. Few of the enterprise level users which are actually using these services are McDonald's, 21st Century Fox, Activision, Netflix, and all those things. So these are the prospective clients of AWS which are using AWS services at scale in a huge amount of data. So it's not just all about numbers, but it's also about fact which prospective clients are using AWS. There might be some reason behind it. And if you talk about global presence, so AWS global infrastructure is spread across the globe. If you talk about US Pacific regions, they have 4 regions in US East 1, US East 2, US West 1, US West 2. Okay, it also has government specific cloud, which is a dedicated cloud service only for US region, which is Gov Cloud. So Gov Cloud means government cloud. That is especially located in US West region where the White House is situated. And it has AWS regions, AWS availability zones, AWS data centers, AWS edge locations, edge points, and those things. So region is nothing but a geographical location such as US West 1, US West 2. But when you talk about availability zone is actually the data centers which are hosted in specific region. For example, if we have US West 1, it will have 3 to 4 availability zones, and each availability zone will be at least 100 miles away from each other, because if some natural calamities occurs, so the data center won't get affected from one to the other one. So to prevent such natural disasters, AWS has made sure that there are enough distance between one availability zone and the other one, so that the data doesn't get lost in any condition of the end customer. So while configuring your infrastructure, you should be using multi-AZ, multiple availability zones, so that even if one data center goes down because of XYZ reason, the other data center would have some backup data of your system. So it's always recommended to go for multi-availability zone rather than single availability zone in one particular region. Let's go ahead. So this is the list of the regions available in AWS. As you can see here, US is one. In US Pacific region, there are 4 regions. In Africa, they have 1. AF South 1. In Asia, they have total 6 regions, and Mumbai is one of them, where India hosted region is available. There is one Canadian region. There are again 5 European regions, one Middle East, and one South America, Sao Paulo. So these are the number of regions which are available across the globe to use, and the nearest region you can select as per your current geographical location. And how to choose an AWS region? Definitely, you need to go through a few of the factors like compliance, proximity. For example, if you are targeting your customers who are from Canada, then you have to go for the Canadian region, right? So that will provide you the nearest proximity, and that's where the performance will be most optimized. Otherwise, if you're choosing your region from AP South 1, from Mumbai region, and your target customers are at US, then they may face some latency performance issue. Okay, so that's where you have to keep in mind what are the nearest possible regions, what are the compliance requirements, because various regions have various compliance requirements, and the available services, because few of the regions don't have all of the services available. So few of the services are disabled in some regions, so you have to take care of that as well. And definitely pricing also varies from region to region, because there are some region specific expenditures, because some regions do support some uh, activities behind it, but some doesn't, so it will cost something extra. So these are the basic factors which you should keep in mind while selecting a specific AWS region for your computing solution. And as I said, like AZ, so availability zones are nothing but just actual data center, and it should be minimum two. AWS maintains at least two availability zone in each and every region. So let's talk about AP Southeast. So if you have AP Southeast 2, it has three regions here. AP Southeast 1, AP Southeast A to B, AP Southeast to C. So A, B, and C. There are three already zones in which region AP South is 2. So that's how you can actually get the already zones in each and every region. And as per the AWS best practices, you should go for multi-AZ, as I said, to make sure even if your data is lost in one data center from one already zone, we can have it recovered back from the other AZ. AWS point of presence, which is also known as edge locations. Amazon has 216 points of presence, which are 205 edge locations and 11 regional caches. So when you talk about the point of presence, then it is really performance effective solution, because if you have a specific region in India, but you want to provide your customers from US to access your service, then you can deploy your point of presence in US. So actually what will happen, even if your infrastructure is from India, you can serve your customers at US if your point of presence is available in the United States region, and content is delivered to the end user with lower latency. Even if your infra is in some other geographical region, then too you can serve your customers better with lowest possible latency if you have your edge locations and caching in place. Tour of AWS console. So fine, we should go for the AWS console tour now, because depending upon that, we are going to plan our rest of the session. Just a minute, let me switch to the other network for having the AWS console. Yes, this is where you should go. Let me copy this account ID. Okay, fine. So let me log out first of all so that I can show you right from the beginning how the Amazon console looks like and what exactly we are going to configure, log in. We have one query here, maybe a statement in the chat. Which are the fundamental parameters to be considered while hire a cloud space from cloud vendor for a generic smart farming ecosystem? Covers WSN, IoT, mobile apps, etc. So the fundamental parameters which we should consider for such requirement is the amount of computation required, is the amount of scalability you are anticipating, the amount of end customers you are anticipating. For example, if you have a specific region in your mind, like you are going to deploy your applications on Africa location, then you to go for that specific region first of all, then you to decide like what amount of computing requirement you have, what amount of RAM memory, what amount of CPU, which processor, how much amount of hard disk you need, which IoT devices you are looking for, which mobile applications, Apple, Android, or exactly which deployment strategy you're looking for. If you talk about WSN, then which exactly wireless mechanism you are going to implement in your ecosystem. So these are few of the fundamental, properties which you should keep in your mind while designing such architecture on AWS Cloud. So I hope that addresses your concern. And taking that as a note, let's go to the AWS console. So I hope my screen is visible to you.
Yes, sir.
Okay, fine. So this is the landing page, aws.amazon.com console, and we are just going to click here to sign in to the console. And here I will provide my account ID. This is my IAM username, my password. I'm just going to click on the sign in button, and that's it. We are logged in, just like any other platform like Facebook, WhatsApp web, or Twitter, or anything else, LinkedIn. So this is my management console from where I can host all the services I require. So even for IoT, I just need to search here in the search box IoT. That's it. We can get lots and lots of service results in the search box. We can go to the IoT core, IoT site-wise, IoT analytics. All these services are available. We can just configure it as per our requirements. Whatever the IoT devices you are configuring, those requirements can be facilitated from the search box. For example, if you want to perform some analysis on your data collected on the IoT devices, then you can go for IoT analytics and process those mechanisms. If you want to purchase a server, which we just gone through here, is EC2. So EC2 is a computing service where you can actually deploy your scripts, deploy your Python scripts, and execute it on the server. So EC2 is nothing but Elastic Compute Cloud, which will provide you some computing mechanism, and that's where we are going to cover it. Let's switch to the other tab. So as you can see in the URL, I am as of now situated in which region? US West 1, Northern California. See, as of now, you can see like I don't have access to the instances. There's a reason I will get this error, API error, because I don't have access. So from IAM, if the administrator don't don't give me access to this specific service, then I will not be able to access that EC2 service. So here, if I go to your instance running condition, it will it will throw me an error message. You are not authorized to perform these operations because the administrator user has not granted me the access to the EC2 service. So that's how you can manage your access in the cloud. On using which service? Using IAM. So let's go to the IAM service, which is Identity and Access Management. So you can go here, IAM. And my user also cannot modify or add any specific IAM services here because even I don't have access to the IAM. So even if I go to IAM and try to modify my user service access, I won't be able to do that because I don't have access to the IAM service. So as you can see here, I have 16 users. Okay, all these users. From that user, I need to search my user, which is D Rana. Okay, this is my user. Yes, so this is the level of access I have as of now. As you will see in the permissions tab, in the permission, I have access to all of these services. But here you cannot see EC2 service, right? And there's the reason why I cannot actually create those EC2 servers because I don't have access here. So my user don't have access to EC2, so I can't create any server or modify or at least list those servers. So EC2 full AWS web full access, all the services is having full access to this user, but rest of the service which is required is not having access to it. So let me sign out and let's sign into some other account where I have access to the services so that I can demonstrate you guys. I need to stop my sharing. First of all, let me sign into the other account. Yes, I am ready now. So let me share my screen again. Okay, I hope you guys can see my screen now. So I have entered the other account details. This is my other account ID. I have entered the IAM username and the password. So let's get signed in. It's not allowing me to sign in. Let me try it again. Okay, let's do one thing. We can create a all new account here. so that I can demonstrate you how to create a new account as well. So let's go to the AWS website and sign in using a new account. Create account. You can just search it here. Sign up for free AWS account. Get started. Here it is AWS free tier. So that's why you can get solutions on AWS free tier as well without spending much cost. So as you can see, like it provides an opportunity to explore products for free with offers, including products that are always free. If you go for free tier, then it will not charge you anything. But if you exceed your limits and go beyond the free tier edition, then you can have some billings in your invoice in the monthly or maybe twice a month billing cycle. Let's go to the sign in the console. Here we are just going to create it again. Create a free account. Yeah, here we are. Create a free account. Let me copy the link. You can note it down here somewhere. I am entering here my email. gmail.com. Account name can be Rana Freelance. Now we have to verify our email. Let me note this down. Verify. Confirmation mail is already been triggered. Let me just confirm it. Yeah, here we have the no reply AWS email verification, and this is my code. We have to enter this code here and click on the verify button. That's it. We have already created email account and it's verified as well. We need to set our password. I am just setting up my password. Step 1 of 5 is completed. Step 2, free tier offers are always there. I need to enter my how you are going to plan. Definitely it's going to be a personal. It's not a business. If you choose business, it may don't offer you some free services. So if you have your personal requirement for R&D or such kind of activities, you should go for a personal one. Let's enter full name, phone number, my region is India, so I'll go for India. Address is something you can enter straight away. Yeah, let's continue to step 2. I have to check mark this, read the agreement and terms. Here we go, need to enter my credit card, debit card information, and also I need to confirm that I do have a PAN, which is for India based location identity verification. So just let me stop sharing my screen and enter these details first. Then I will share my screen back. You can enter anything like credit or debit card, it won't mind. So you can enter any one information, whether you can enter your credit card, or you can also enter the debit card information. Whatever you have, you can utilize it. I'm using here my debit card information. Also need to enter the expiration date. Now need to enter the card holder's name. So let me enter my name, and the last thing is a CVV. So let's just do it. If you have your PAN card number from India location, then you can enter that details. And now you can click on verify and continue, which is the third step of this process. The very first transaction going to be deducted is of 2 rupees here, just as a confirmation that your entered transaction details is genuine or not. So OTP has been sent to my registered mobile number. Let me check. I haven't received any OTP yet. So let me click on. Yes, you still did not receive your OTP. I still haven't received any OTP. Month expiry month is Jan and year is 20. Let me set my ATM pin. So OTP again sent. So let me check my SMS again for the OTP. Let's just continue with the existing account. So this is the step-wise information how you can create your account based on the credit or debit card details. And let me enter my 12-digit account ID. This is my username and password. So I have shared my screen, and again we are back here in the AWS console. So from AWS console, we can access all the services which we need, depending upon the level of access we have. If we have access to specific service as per the predefined access permissions from the admin user, then we can definitely create resources, we can destroy resources, we can modify resources as per the requirement. So this is the console overview which we have gone through. And moving further, the cloud computing part. The tour of the AWS console, we have gone through how to use our credentials to log in into the console, because there are two types of access. One is the console access. Second is the programmatic access, which is also known as AWS CLI access. So I will just show you how AWS CLI access works, because AWS CLI access requires two keys, which are credentials, basically just like username and password. So we require two keys for AWS CLI access, which is access key and secret key. So using these two keys, we can actually log in into our AWS account from the AWS CLI. So what do we mean by CLI? CLI is something but is nothing but just a command line argument, command line interface. So from the from the bash, from the Linux system, from the terminal, you can actually access your services of the AWS cloud using commands. And that command starts from AWS because it's a AWS CLI tool. So AWS tool provides you a programmatic access to your AWS account, through which you can list, read, write, you can create resources, you can delete resources, whatever you need through commands. So basically there are two types of access. Very first one is through console, which I just show you, using your account ID, your username and password. The very second type is the programmatic access, which is accessible using access key and secret key. So by commands also you can perform the same operations which you can perform using AWS console. So AWS console provides you a UI interaction, a user interface in the browser. But in case of AWS CLI, you can access the same services using commands, which is known as a command line interface. So most AWS services are region scoped, and some of them are global, which is not region scoped. For example, AWS S3 bucket, CloudFront, these services are not region specific, these services are global. So only specific services which are region specific are EC2, Beanstalk, Lambda, recognition, SNS, SQS. So these services are region specific. Which region we are targeting for? Our end customers like Asia Pacific, Mumbai, Tokyo, Singapore, or whatever region we are targeting for. But if such services which are global will not affect any region scope activities, it will be available throughout the globe. So from any specific geographical region, you can access it. Now we are going to cover the IAM section, as I just demonstrated from the console as well. Even if I didn't had the IAM access, I can just read all of those informations from IAM. So that was one of the parts which I just covered from the console. And in the IAM section, we are first going to cover the users and groups. So in case of IAM is nothing but an identity and access management. It is basically a service where you can create users, where you can create groups of users, through which you can provide specific access. For example, if you have requirement of providing access to only EC2 service, Beanstalk service, Lambda service, then you can create a specific group, attach all those access policies to this group. So whatever users which are attached to the group will inherit all the access policies which are attached to the group. So you don't have to go and specify the access policies to each and every users. For example, if you have 100 users, you can create one group of 100 users and attach all those access policies to the one group. So all of those 100 users will inherit those access policies which are attached to the group. And that is really a time saving process. You don't need to literally go through each and every user and attach those services access. And this is how the pictorial view you can get it here. The group of developers, the group of operational, the group of audit team. So all of these groups may have some overlapping access, and maybe some users would be part of both the users, developers group, audit group, as well as operations group. So it depends upon those things. And definitely one IAM user can be part of multiple groups as well. So here we can consider a group as a collection of multiple users where each and every user can be part of one or more groups. Because depending upon his roles and responsibilities, that particular IAM user can have access to multiple groups and all of those services which are being part of access in that group level access specification. And moving further, this is an IAM permission example, how it looks like. Users or groups can be assigned signed JSON documents called policies. So these are basically JSON document through which you can assign policies to a specific IAM user. So for example, in the agriculture project, you have a specific requirement of 10 users, and you have created specific groups of 2 to 3 users. So each and every group will have some JSON policies attached to it, which will specify the level of access, right? The level of access. So the level of access will be provided by JSON policy. So this is the document which will define which level of access each and every user should have. So this policy defines the permission of the users, okay, which are attached to the specific group. So if this policy is attached to a group, then all the users of the group will inherit this IAM policy. In AWS, you apply the least privilege permissions because you cannot provide a open access. You have to restrict your IAM user access at least as possible, as least as possible. If there are some vulnerable activities, if a user has obtained the access which he or she shouldn't have, then he or she can perform some malicious activities, right? So to avoid those conditions, the administrator user must ensure that their specific user should have only that specific least minimum access which he or she should require. So depending upon those requirements, we need to manage our IAM permissions very wisely. And moving further, like IAM policies inheritance, you can also inherit one policy from the another. For example, there can be a nested policies. So one policy is inheriting the policies document from the other one as well. So all these kind of policies in IAM can be inherited from one to another, so that a nested form of policy can be obtained. So you can see like developers group has specific access policies, audit group has specific access policies, operations group has specific access policies in which specific users are attached in overlapping conditions. So this user Charles has access to developers as well as audit team both. In case of Dev, it has access to operations as well as audit team both. So this is how it would actually look like when overlapping of IAM policies occurs from one group to another. Uh, Now let's understand the structure of IAM policy. When you provide a access policy for the cloud user, AWS cloud user, how AWS policy actually looks like. So very first one is the version. So it would provide you a specific version of IAM policy, which is defined by AWS. Second is the ID. ID is system generated. So AWS itself will provide you a specific ID. You don't need to provide any ID value. Second is the statement. So in statement block, you actually provide few important information such as SID. SID is the service ID, which you can provide by yourself, but it should be unique for each and every IAM policy. Then it comes effect. Effect means if you want to allow or deny. There are two possibilities: allow and deny. So whatever operation you want to perform, you can just specify here whether you want to allow that specific policy to perform the following operations, or you want to deny the specific policy to perform that operations. So in the principal block, you can actually specify IAM user or IAM resource. Resource means a Lambda service is a resource. EC2 service is a resource. So whatever item which were created under specific service is considered to be as a AWS resource. Okay, and in that specific resource you can get ARN. ARN stands for Amazon resource name. ARN stands for Amazon resource name. So ARN is a unique value to identify each and every Amazon resource across your account. Okay, so that ARN will help you to identify your resource and specify only that specific resource in your policy to apply those access permissions. And in the action section, you can actually perform the specific action level access requirement for, so that policy describes which are the possible activities that can be done. So in these possible, so in this IAM policy, it will allow S3 object, get object, and S3 put object access to which user? To ARN AWS IAM root user. So the principal user, which is a root user, will have access to the S3 service for get and put object. Get means to download, put means to upload. Okay. So in S3 bucket, which is also known as a Google Drive kind of storage. So in the S3 bucket, this policy will allow the root user to upload and download the data. Correct. So these IAM policy will be applicable to which resource? It is also specified here in the form of ARN. In the resource section, you can see the my bucket. So only to my bucket, the root user can upload and download data. So wherever this IAM policy is attached to specific IAM user or group, it will make sure only root user will be able to access, will be able to upload and download the data to and from my bucket S3 resource. So this is what a IAM policy looks like, and this is a basically JSON template using which you can manage your access for any specific IAM resource or any specific IAM user group or IAM or any specific AWS services. So even multiple services in AWS account needs to have access, right? For example, your Lambda service, if access is your S3 bucket, then IAM policy should be attached in between. So that IAM policy defines Lambda can perform which operations with the S3 bucket, whether Lambda can read, whether Lambda can write, whether Lambda can modify, whether Lambda can upload, download, modify, delete, whatever operations are accessible, whatever operations are assigned in the IAM policy, all those operations will be accessible by the specific Lambda user. We have something in chat. Okay. So this is how we are going to actually design a JSON document which will provide access specific requirements, because in cloud we have to provide access specific requirement for interacting from one service to another service. For example, we have IoT service for IoT devices in the agriculture industry. So for that specific IAM related requirement, we need to create policies so that that IoT device will communicate with some other IoT device. So both the device will have some access permissions in between, which can segregate, which can restrict one device to the other device to access only those specific access requirements which are specified in this IAM policy. So that's how the overall access management will occur on the cloud. And here we go with the password policy. So definitely, even if you use Gmail or YouTube or any specific application, the password policy is something which is needs to be strongest. So password policy is also configurable in AWS console for each and every IAM user. So whatever user is there, you can set a specific password policy that it must have alphanumeric characters, it must be 10 digits long, it must have a special character, right? It must have an uppercase and lowercase character. So all those combinations can be covered in the password policy document, and you can attach this password policy document in the each and in the IAM group, or else you can attach this password policy to each and every IAM user. So whichever user is part of your AWS account must abide with this password policy. Okay, so whenever a user logs in, it has to, he or she has to provide a strong password as per the policy defined. So if the policy has at least 8-digit long password with one upper and lower character, then that specific IAM user, whenever logs in, he or she needs to make sure that the password should be as per the policy defined. Otherwise, that user will not have access to the AWS account. So these kind of configurations is possible when you design an IAM policy for password restrictions. And also you might have gone through MFA. What is MFA? MFA is nothing but a multi-factor authentication which occurs with a mobile virtual device as well. For example, if you use Google verification, if you use Microsoft Authenticator application on your mobile devices, right? You get a code which gets expired every 30 seconds. So that code can be utilized to authenticate your IAM user. So that's a multi-factor authentication. Apart from your username and password, you also need to enter that verification code, which is available from your mobile devices using any virtual MFA application such as Google Authenticator, Microsoft Authenticator, or any such kind of standard application which is available on Play Store as well as app stores. So AWS also recommends you to enable this MFA. So to demonstrate this MFA, let me just go to my console. And if I go to IAM service, you can find it very much clearly here what AWS has to say about it. You can, in this specific user account, I haven't enabled MFA. So you can see it here as a warning, which are two security recommendations. What? Add MFA for root user and also add MFA for yourself. So whatever the root user account would be there associated to this account, which is 9623139, must have enabled MFA. Okay, and there is also a IAM policy through which you can configure MFA mandatorily for each and every user, whoever is part of your AWS account. You can mandate each and every user of your account to enable MFA, and this is security best practices recommended by AWS. So for example, there is a user Alice which has password. It is still not enough. Password along with MFA is equal to successful login, because AWS mandates each and every IAM user to enable MFA, so that no intruder can have access of your AWS console intentionally or unintentionally. Okay, fine. So let's move ahead with the next one. Yeah, as I said, with the MFA devices, you have following options. Okay, you have your Google Authenticator, you have Authy, which is Amazon Authenticator app. This is known as a virtual MFA device. Okay, and which is a universal two-factor authentication security key, which is a 6 digits code, which has a 30 seconds expiry. YubiKey is again a physical verification code device through which you can actually insert it into your USB ports and enable those MFA. So it's a a multiple root, and it's kind of multiple root and IAM user single key. So it can be used as a security key for login into your IAM account. And there are also hardware key MFA devices available in the market, such as some products provided by Gemalto as well as SurePass ID. So this will provide you a 6 digits MFA code at every 30 second interval to authenticate your IAM account. And both of these devices, as you know, are third party solutions, so that you can integrate it. So first of all, you have to register your MFA device to your AWS account user. Then you can continue using these 6 digit IAM, uh, 6 digits MFA code to log in into your AWS account whenever you have to log in using your username and password. Now let's go to how can users access AWS. As I said, there are 3 to 4 ways. So very first one is management console. Here you can, as I said, protect your password with MFA. So your password, IAM username password along with MFA will enable you to log in into your management console. Now comes the second one, which is a command line argument, the command line interface, which can be done using AWS CLI tool. So you need to install AWS package on your system if it's a Linux system, or else you can install your exe file on a Windows system, and then you can execute AWS commands uh, to actually get those AWS operations. For example, AWS read, AWS write, AWS delete, AWS modify operations for all the services which are EC2, Lambda, IAM, or whatever service access you want, your IoT devices, okay, your mobile applications. All of these operations are possible on each and every service using AWS CLI commands. The third one is software development kit. So what do you mean by software development kit? Software development kit is a toolkit, is a framework provided by AWS to develop the AWS specific operations in programming languages such as Python, JavaScript, TypeScript, Java, Ruby. Okay, so you can actually write your code using these SDKs to perform those operations. Okay, to perform those operations, you can write your SDK code. So using Java SDK, using Python SDK, using JavaScript SDK, you can actually write those code. Then access keys are generated through the AWS console. So access key and secret keys is a type of CLI tool which you can use to basically access your AWS console using access key and secret key. So these are two basic keys which you need to provide enable in order to enable the CLI access of AWS. So just like password, you have to enter these two keys, access key and secret key, and that's it, you are done. You can configure your AWS CLI access for the system. And this is a screenshot which I have captured here, using which you can have those access keys and secret keys. So secret key is visible just once, and access key is visible on the IAM console, so that you can identify which access key you had created in the past. It also specifies you the created date timestamp, so that you can exactly identify the time based constraints, and you can also check the status whether it's active or inactive. You can make inactive as well if this access key or secret key has been exposed somewhere. So in order to secure your account, you can inactivate these access key if you are not sure about the access, that whoever may have received these keys still can't access your account because you had marked this as inactive. Moving further, what's AWS CLI? So AWS CLI, as I said, is a command line interface through which you can operate your AWS executions. For example, if you want to upload some data on your S3 bucket from your IoT device, then what you can do is actually configure your AWS CLI access on that device, and then use AWS commands. Use AWS commands to upload data from your IoT device to the S3 bucket. So IoT device must have some prerequisite install AWS packages for AWS tool, so that AWS can be configured using access key and secret key. Okay, it will require two keys to configure your CLI. So once you have that configured, you can directly execute these commands. As you can see in the screen, there is AWS S3 CP. S3 is a service, CP is an operation. Then you can provide your source location. For example, I have some data here on my sensor name myfile.txt. So that's in the actual location. Okay, that's the source location, CP. And then the destination is to be uploaded on the S3 bucket. So here my destination will be S3 column // then your bucket name and then your file name. So that's how you actually going to upload your data from your IoT device to the S3 bucket. And you can process, filter, operate all those, you can perform all those analysis on the data which are captured on the S3 bucket on the cloud. So this is the beauty of cloud, how you can operate it. There are n number of possibilities. You can use SDKs in any specific language like Python, Java, JavaScript, Ruby, or anything, Perl. So these programming languages are supported by AWS. So you can use those SDK as well as this option, which is AWS CLI option. So these are the possible, workarounds and solutions, whatever you want to play around it with. You can also get, good amount of documentation. For example, if you want to write your Python code using AWS SDK, then you can just go to Google. Let me just show you something. AWS SDK for Python. You can just search it right here. The very first link which I get is the AWS SDK for Python. You can find it on the official Amazon website. You can also get the documentation. You can also get the tools, and this is the command which you should execute to install this Python SDK. for AWS operations. So, this is a small code snippet through which you can iterate your number of EC2 instances for I in EC2.instance.all. If I.state name, you can specify a name. Stop I.start means whatever instances are marked as stopped, it will be started. So this is a sample code which you can consider for implementing your functionality based on your requirement. So this is how we are going to conduct the overall, operations in the cloud. You can use Python SDK. You can use AWS CLI by executing the AWS commands. And what's AWS SDK? As I said, like it is language specific API calls. So you can just import your library for any specific language like Python, Java, or Perl, anything. Just a minute. Okay, fine. So let's continue with the AWS SDK. As I said, like we can have it in various programming language support. Here we have the list of SDKs which are available on AWS platform: JavaScript, Python, PHP, .NET, Ruby, Java, Go, Node.js, C++. So whatever programming language you are familiar with, you can use that language to operate the AWS components. For example, if you want to host an IoT device, then you can write a Python script to host your IoT device on the AWS cloud using the Python SDK. So there are predefined IoT libraries. There are predefined EC2 servers. The libraries. There are predefined S3 bucket libraries which you can directly call and use in your code as per your requirement. So whatever the business criteria, business logic would be, you can apply those logics in your programming language using a specific AWS CLI tool or SDK. You can implement all those business use cases into your project implementation. So also in your final year project working, or else you can implement it in your project research and development purpose. You can also implement in your uh, thesis, or maybe into your research papers. You can demonstrate the use of Python scripts or Java, a programming language, how you utilize those SDKs of AWS, and how the agriculture industry will processes which are involved in the agriculture industry can be automated using these implementations on the cloud. So all those AI ML activities which the previous session has been covered, all those activities can be performed in the cloud as well using the same SDKs. So there are specific mobile SDKs and IoT devices. Okay, and example for that is like AWS CLI is built on AWS SDK for Python. So even AWS CLI itself is something which is built over some SDK, which is for Python scripting. So down the line, AWS CLI tool also uses the same programming language, so you can directly use that SDK code as well. Just a minute, give me a moment. Okay, fine. So I'm back again. Yes, as I said, like even AWS CLI has been implemented using Python SDK. So similarly, you can develop the scripts as per your business use cases for the project planning or for the cloud implementations. So the same programming languages can be utilized similarly for Java, JavaScript, Ruby, Python. Uh, and moving further, we also have some IAM roles for services, because policy and role are two different things. You can think of a role as a combination of policies. So IAM role has multiple policies inside it based on what it makes it as a role. So for example, if you have your EC2 instance communicating with an SNS service on the AWS Cloud, so the EC2 service will have specific access requirement with the SNS service. So what happens here, you need to attach a IAM role so that the EC2 instance can access only that specific access policies which are mentioned in the IAM role to communicate with the SNS service. So even when two services are interacting, communicating with each other, there must be an IAM role in between to manage access between two services. So that's how IAM roles will help us to manage the access policies when two or more services are communicating with each other. And this is the pictorial view how you can visualize of a EC2 instance having access to an SNS service, a Lambda service, or SQS, S3 bucket, or whatever service we want to integrate it with the EC2 functionality. So common roles here are like EC2 roles, Lambda function roles, cloud formation roles, and all these things. So Lambda, as I said previously, is a serverless computing model, and EC2 is a server-oriented model. So both these have two different use cases depending upon your requirement. But yeah, especially for startups, they are going for serverless computing. That's where Lambda will help us as a cost-effective solutions. And just a bit of information for you guys about the cloud formation here. So cloud formation is basically again a JSON kind of template from where you can spin up your AWS resources in automation way. So when you click button in the UI using AWS console, it's a manual process. You need to go fill up the form and then create your resource, right? Manually in the AWS console. But what if you have script itself spin up those resources which you require? So those scripts can help you to automate the creation of those resources in the IAM, in the AWS infra. So CloudFormation is a infrastructure as a code service available in AWS through which you can spin up your resources in automation way. So there are YML, there are JSON scripts which are available, which are supported, and through those scripts you can actually create your AWS resources in automation. So assume like you have one script, you just need to execute that script and that's it, done. Your resources will be there available on the AWS infra. But in case of what you don't have those scripts, you need to actually log in into your console, go to the specific service, fill up the form, create buttons, configure it, and then it will create. So that is a bit long-term process. But development of the scripts will be just one-time process. You can create those scripts once and then create those resources n number of times with ease. So that's what the overall benefit you get with the automation. And definitely in cloud, most of the industry leading companies as of now are moving towards automation, are moving towards integrating the automation scripts with one point to another. So definitely if you want to go with the industry standard solutions, you should go for automation. So there should be minimal manual processes involved in the overall ecosystem. And definitely it would be consistent as well, because what happens is like if we as a human create some service, it may have inconsistencies from one infra to another. We may miss out some configuration, but what if we have scripts will never miss those configurations, right? Whatever configurations are mentioned in the script, it will definitely create all those resources. So that's what benefits, that's what accuracy we get with the automation scripts. And that's what we are moving towards these days. And IAM security tools are also available for cross account access, for the credentials reports. For example, somebody is using stale credentials which are more than 60 days old, and you have a security check running across your account at every week. You can get reports like which credentials are weak, which IAM user credentials needs to be strengthened more, right? So that your user's account doesn't get hacked away, and any critical information may get lost. So to avoid those situations, you can go through these credential reports at regular interval of time and take proactive decisions based on those data. So IAM Access Advisor is something which will provide you a useful information, a guidance to you based on what you can actually enhance your existing access privileges. For example, if there is something very open access given to EC2 service, then it will definitely advise you to narrow down those service access to specific access like read access, write access, modify access, delete access, or else full access if and if only required. So unless until you don't have a specific access for full access requirement, you don't need to specify that full access. Otherwise, what will happen? Even if your intended audience is not supposed to delete resources, they can or they might accidentally go and delete those resources, which may hamper your overall project work. So that's where you have to wisely manage your access requirements using Access Advisor. It will definitely help you a lot to enhance those access levels in IAM policy. And these are a few of the guidelines and best practices which is taken from the AWS standard documentation, like one physical user for one AWS user. So there shouldn't be any multiple user accounts for even one specific physical access. And assign users to groups and assign permissions to groups to manage to access, enable MFA as I said previously, and to have strong password policy. And definitely you should never share your IAM users and access keys, secret keys to anybody, so that nobody gets access to your AWS infra. And here we go, like this is the shared responsibility model for IAM, like what AWS is responsible for and what you as an end user of the cloud is responsible for. So AWS is totally responsible for the infrastructure, the global network security, that nobody is going to actually get the physical access of the infra. But yes, if you have not configured your infrastructure properly, then maybe some intruder get access to your system using any leakages or using any loopholes to your infra because of any security a risk which you have taken while implementing the infra. Using those loopholes, they can get access of the infra and may hamper your overall project timeline as well. So configuration, vulnerability analysis, compliance validations, and all those things are being checkmarked as the AWS responsibilities. But at the same time, you also need to take care of all those responsibilities which are mentioned at the user end. So as a cloud user, we must understand what are our responsibilities and what AWS is responsible for. So we as an end user must go through and analyze access patterns, review the permissions at regular interval of time, so that if there are any extra privileges given which is not required, we can cut down those access and provide least minimum access to each and every user. Similar way, we should also keep on rotating the keys. For example, access key, secret keys for CLI access should get rotated every 30 days. So, those access key, secret key should get changed at regular interval of time as per the predefined time frame, like 30 days, 60 days, 90 days, whatever the policy we have set as per our organization. And this is the summary of which we have gone through so far in IAM. Auditing access keys, secret keys for CLI and SDKs. Even for SDK, even for Python SDK, we should have access key and secret keys. So that is, pretty much a critical part of the overall system to have access of our infra. So that's where access key and secret key should be stored somewhere in a secret place, like a secret manager or a vault, from where those information, which is a critical information, can be retrieved in a secured way. And rest of the summaries also include, like, we have gone through policy, we have gone through roles, we have gone through IAM users, groups, why to create groups, where to create groups, how groups are related to the users, right? And what are the security best practices in IAM laid down by AWS itself. So all of these activities we have discussed and gone through in the AWS console as well, just like going through the AWS console from the browser menu by logging into our AWS console. I also demonstrated you a way to create your AWS account. So definitely you can create it on your leisure time and practice on your own. But make sure one thing, whatever resources you create, even if those falls under the free tier edition, you should switch off, you should terminate those resources as soon as your practice work or R&D activities are done. Otherwise, what will happen if it goes beyond the free limit, then it may charge you something, and then you have to pay even for unused resources. So please make sure you switch off the resources once your practice work, once your R&D activity is been done. So this is a kind of prerequisites which I have passed on to you. So please follow those instructions carefully. And that's it from the cloud computing overview. We have also covered the IAM service layers. We have covered it from the infrastructure, actually going through the users, after going through the IAM policy as well. So here, let's go through some other I have here to just present you guys. So what if we want to build a ecosystem for a specific to agriculture industry, or any irrigation system, or any crop investigation system, where we need to check the quality of the crop, we need to check the quality of the soil. Okay, so for all those requirements, what we will need actually is a computation power, right? So to write a specific code is a different thing. Okay, to perform those operations, we need to write some code. Definitely, there's a separate topic, but after writing the code, what we will actually need on the cloud is the computation part. So to deploy that code and execute it on the cloud, we will actually need a service which is called as EC2. EC2 stands for Elastic Compute Cloud. So it will provide you the computation power to execute a code on the cloud platform. And here in this case, we are going to use AWS Cloud, in which the service which we are going to use here for providing the computation support required for the code is going to be EC2 service. So Elastic Compute Cloud is going to provide us a computation power like a CPU, RAM memory, hard disk, and all those requirements, the processor type, and all those things, depending upon the requirement. So we'll go through these principles very soon. Just a minute. Okay, fine. So let's go through a few of the basic terminologies. As I have just given you overview about what is EC2, why it is required, and you know uh, which are the types of EC2 instances which we are going to get is what we are going to cover in this presentation. Okay, so we have some other question query here in the chat box. Is there any real-time simulation service available in AWS to walk through the cloud services other than free tier login? Other than free tier login to walk through, like there are some paid version of the services which we are going to cover, but not exactly right now, because it's going to be a paid version of it, such as Kinesis, which is a live simulation of video streaming. For example, if we have the farming property somewhere and we have some drone cameras which are streaming the video live on AWS servers, so that Kinesis Firehose will actually stream those video and get it done live to our mobile applications or maybe whatever web application we have subscribed to. So yes, there are some live simulations possible, but it will have some implementations also. We need to write some code. We need to write through the basic infrastructure code as well as the programming code in Python using the SDK, as I said. So all of these simulation, all of these project specific implementations are possible, but that is subjective to the project definition as well as the research and development thesis topic. So whatever the topic which we are going to define, whatever use case which we are going to cover, it is totally dependent upon that specific definition. So the use case which we get, depending upon that, we can simulate overall ecosystem, we can simulate overall architecture. It is totally dependent upon what we are defining as a project outcome. Now, for example, if in a use case we define like we are going to cover property of soil of a specific irrigation, in that particular requirement we have to deploy drones, we have to deploy some sensors, and that sensors will capture those soil qualities from different geographical regions, and then from that data collected we can process some information on the cloud. So all those kind of simulation, all those kind of operations can be performed on the cloud. But when we have those devices available, when we have those actually a property available, we can distribute those sensors across the global regions, and then our simulation can be possible. Otherwise, it can be, a simple demonstration of a sample data which we have collected as a Excel sheet. So based on those Excel sheet or specific spreadsheet, we can extract the data and then process it on the cloud. So this is one of the workaround which is possible in this specific use case, and but it may exceed the free tier framework, because it will definitely charge you something, because these advanced services are not covered in the free tier additions. We may need to exceed and go up to some costing limits, but definitely those costs can be estimated using AWS online calculator. Let me just share my screen and provide you a example here. You can just go for AWS calculator. The very first link which you get is the pricing calculator. Okay, so I will just show you a quick demo how you can have some idea about how much cost you are going to incur. So here you can create an estimate. You can search for services. For example, if you are going to create an IoT server, then if you are going to have some analysis, you need to go for AWS IoT analytics. You can configure it. You can give some name, IoT analysis for soil quality. Okay, and in the data store you can specify the amount of data which you are going to anticipate in the overall ecosystem. For example, the number of devices which you are going to deploy is going to be 1. Data generation by each device in MB per month or GB, KB, whatever you would wish to have. For example, you have 1 MB, and data pipelines monthly, like how much streams of data are going to be processed, are going to be uploaded to the IoT server. So that stands for one pipeline. So if there are 10 pipelines, we need to specify 10 here for the specific requirement. And data queried per month. So queried per month is a query is what do you mean by query? Query means to get the data. So whatever data are stored on the IoT analytics, to get that data back on the visual dashboard, that is considered to be one query. So one query means the actual GET request to display those collected data. So we assume here we have 100 MB per month data queried, because we can collect data once, but we may require to display it 100 times more than that. And here we can actually go through the calculations of how they are calculating that cost, and based on that we can create our infrastructure on the cloud. So it won't be a nightmare for us. We can exactly have an idea how much amount of funding we will require to raise for any R&D activity. So those kind of budgeting planning, all those project planning can be done using this online tool, which is AWS pricing calculator. And if you want to have some execution on query scanning, you can also include those costing. You can also utilize the custom analysis if you want. So all those metrics can be entered here, and you can see the monthly cost for this user is going to be 0.02 USD, and yearly is going to be 0.30 USD. So similarly, you can create all those resources, and you can add it into the estimate. You can add service. Now this time, if you want to store your data on the S3 bucket, you can configure this S3 bucket to actually anticipate what the costing would be. So I'm taking S3 storage for collecting data from sensors. Okay, and we need to also provide these data information, like how much GB per month is going to be stored on the bucket. Like for example, 10 GB. What are the request, put, copy, post, list requests? Then we can say 1 million. Okay. Similarly, same for get, select, and all other requests. Data written by select. So this is again to download the data from the S3 bucket. For example, we are going to download 10 GB. We are going to store 10 GB and we are going to download the 10 GB data. Similarly, we also need to provide data for scanning. For example, if we scan the data 10 times we download, then too it would be 100 GB per month. So this is the monthly estimate, which is 5.84 USD. You can add it. And also for transfer charges, if you want to transfer data outside the S3 bucket, it would be an additional cost. So all those requirements you can specify here and then add it to your estimate. So total billing of your 12-month and year would be 70.38 USD. Then you can get the breakdown of each and every service here, monthly, this much. So this tool will definitely help you to simulate your project work, to simulate your R&D activity before you actually go and implement those activities. So this is one of the possible solution for you to go through and implement, but that's again cost effective. So that's going to cost you something. Is it two basics? So as I said, like for developing a solution, you need to write some code. And once you write that code, you need to implement on some machine, right? You need to execute on some machine, which is a server. So that server computing power will be provided by EC2 service on the AWS Cloud. Like for example, we have Amazon EC2. So it's one of the most popular service on AWS, which is mainly used for renting virtual machines, providing some processing power, providing some computation requirement, providing some storage activities. You want to store some data after processing. So for example, if you have some data from S3 bucket, you need to process them and store it on a hard disk of a system, then you can do it using your EBS. EBS is basically elastic block storage, which will store your data just like C drive, D drive, E drive on your system. And scaling of the services can be utilized using ASG. So you can actually automate the scalability. For example, if you have 1 GB RAM and 2 CPUs, okay, it will have some computing capacity. For example, 1,000 requests per minute. What if that 1,000 requests per minute exceeds beyond that? If it goes 1,500 requests per minute, then you will need some additional computation, right? So to suffice that additional need, you need to automatically scale your resources from 1 to 2, from 2 to 3, 3 to 4. So it should keep on scaling depending upon the incoming request requirements, right? So it will be basically based on your CPU and RAM utilization. For example, your CPU utilization is more than 80%. Okay, then it will definitely spin up a new instance to suffice the incoming need. So it will automatically grow as per the incoming traffic increase. So as soon as the incoming traffic increases, it will automatically scale up a new resources. It will automatically add one new resource into your auto scaling group. So this is how it will provide the automation in the scalability by using ASG. And okay, one more query here we got from student: how to see the log and usage statistics real-time throughput in case of VM of the different resources I have hired in AWS. Please show the screen. Definitely, we are going to cover this part as well in the hands-on session of EC2. Once we cover this theoretical part, we are going to cover the logs, we are going to cover the statistics. So all of these metrics are available in one service, which is known as Cloud Watch. So Cloud Watch has all those metrics available, all those statistics which you are in search for. For example, you can get uh, CPU utilization, you can get memory utilization, you can get hard disk utilization, like how much amount of how much percentage of memory, how much percentage of CPU is being utilized as of now. So all this kind of data you can get in live analysis on your cloud. As soon as you go to your CloudWatch service, you just need to subscribe to that specific EC2 instance which you have hosted on the cloud in the specific region. So depending upon the region in which you host that EC2 instance, you can get all this information in which service, in CloudWatch service. Okay, so I hope that addresses your concern. So we will also go through that practically hands-on once we complete the theoretical aspects here. Next part is sizing and configuration options, because here just like we have a laptop system, we have operating systems, we have CPU requirement, we have RAM requirement, we have storage requirement, right? Similarly, in EC2 as well, you need to select your OS, you need to select your computing resources such as CPU, how many CPUs, one CPU, two CPU, three CPU, four CPU, how many CPUs you require. You need to specify those configurations at the time of creating an EC2 instance. It also includes RAM memory, like 2 GB, 4 GB, how much RAM memory is required to process your computation on that EC2 instance. And for that, you first of all need to test your application on local, like how much RAM is occupied, how much CPU is occupied, right? So all these things can be, first of all noticed in on your local system, and then similarly you can uh, consider those metrics while selecting specific configurations in EC2. For example, if you have observed like your application is consuming 1 GB RAM and a half CPU, then you can choose 2 GB RAM and one CPU on the cloud for the utmost requirement. So based on those metrics, you can select your EC2 configurations for your application. So whatever code you write, you need to test it first on a local, and based on those metrics which you get, you can similarly obtain the same thing on the cloud. And a few other things are also involved, like network configurations such as the network IP. So whatever IP you are going to get is accessible from your outside world as well, if it is a public IP. All these things are configurable and available in the EC2 console. So as soon as you go to your EC2 console, we will go through the hands-on sessions and actually configure a static website on the EC2 instance, so that we can have some idea how the web servers, how the application servers work on a EC2 instance whenever you write your code. For security aspects, you have security groups, which actually works as a firewall. So for any specific computing requirement, you whitelist a port number. For example, if your application is running on 8090 port number, then you need to whitelist that 8090 port number in the security group, right? If you don't whitelist that security group port number in the security group, then what will happen? The end user will not be able to access that application from that port number. So this is why you actually need it. And bootstrap configuration is something which is a a script which executes every time when the EC2 instance spins up. Whenever the EC2 instance get started, it will execute this bootstrap script. So for example, if you want to configure your EC2 instance as a Apache server, as a Nginx server, web server, then you can just write down those installation and setup commands in a shell script and attach that script as a bootstrap script. So whenever your EC2 instance gets started, it will execute all those commands so that your EC2 instance gets configured, set up, and that's it, what you need. So under those scenarios, you can use these bootstrap scripts very much in on hand. And if we talk about EC2 user data, all those data can be downloaded back on your local system as well by using EC2 connection using SSH protocol. So SSH is basically nothing but a a secret shell through which you can communicate it with your local system. If your server is residing somewhere remotely, so using that protocol, you can communicate with your EC2 machine, which is hosted on specific geographical region, even if you don't have the physical access to that server. So here we are going to have a hands-on session here to how to launch an EC2 instance, what will be required, how we are going to launch it on your first virtual server, what exactly it needs, what configurations are there. We will go through all these things here. So to do that, let me first of all stop sharing my screen and go to my credentials file to get those AWS access credentials to log in into the console where I have access to the EC2 machine. So give me a minute. Okay, so fine, let me share my screen now to get into the AWS console. Here we are into the console. Let me sign out to switch into the new account which I have access to the EC2 resources so that we can go through a hands-on session for EC2. Log back in. Let's see what it goes. Yeah, here we have the account IDs. Let me enter the account ID. 6 1 2. So in this account, I have enabled the MFA. So I will enter the MFA code from my Microsoft Authenticator app. The same thing which we discussed while going through the IAM service. This code is valid for 30 seconds only. So let me enter it quickly. See how it goes. Yeah, here we are into the AWS console. So here, let me go to check whether I'm able to access the service or not. If not, then I have to switch the. Yes, here I don't have access to the EC2 service, so I need to switch my role. So switching a role is simply switching to specific another user account. So let me just go through it. I need to enter the MFA code again. Yes, here we are. So basically, IAM role provides you a flexibility to switch back to some other sub account. If you have multiple accounts, then you can switch across the accounts for the same root user. What you actually need is just the account ID, which is 8437 46 1002. The role is TH inbox. Let me check this way. Some process is going on. Let me share it here. Switch role. Let me try it again for the last time. Otherwise, I have to switch the system. Let me cancel this one. Let's go to switch role. Enter the account number. 8437 246 1002. I think I need to switch to some other system. So I will be back again very soon. Give me a minute. Okay, fine. So I am back here with the different systems. So let me just go through my AWS console and we'll share the screen very soon. Yes, so I have my AWS account available. So let me share my screen.
Mr. Dhruv?
Hello.
Yeah, am I audible to you?
Yes, Preeti, you are audible.
Yes, actually, I wanted to say that we have plenary session at 2 o'clock. So, yeah, can you please wind up this demonstration by 5 to 10 minutes?
5 to 10 minutes. It
Is
will
it
take some
possible?
time. I don't think so. It's possible
How much
within five.
time it will take?
It will take at least half an hour to demonstrate the overview of EC2 services.
Okay, you can take up to 120. Can you please try to wind up because people have to come up
Okay.
at 2 o'clock also. So they actually need some time to take lunch also. So try
Okay.
to
If
do
you
that.
want, yeah, like if you want, we can take the lunch break as of now and then resume the share session after the lunch.
After the lunch, actually not possible because we have invited our vice chancellor and other people, authorities also for that plenary session. So you take your time. You just finish it up by 120 or 125.
Okay. Okay. Yeah. Fine. Sure.
Yeah.
Okay. Fine. So. Hmm, let me share my screen. Let me know once my screen is visible.
Not now. Yeah.
It's visible.
Yeah, it
Visible?
is.
Yeah. Okay. Yeah. So here we are into the EC2 service. Uh, we shall go to the instances. So here in this account, in this second, this is my account 8437, has all the access to the EC2 instances as well. So here we can create a instance, launch a new instance as per the OS requirement, as per the RAM configuration, as per the CPU requirement, as per the EBS hard disk requirement. Each and each and everything can be suffice here in the EC2 service. So to first of all understand, it's very much necessary to understand what are the system requirements, because to host a server, it's very much mandatory which OS we require, which how much amount of RAM memory, how much a CPU, and whatever the metrics other than that, like hard disk utilization, a processor requirement, all those things, whether it is a compute optimized, whether it's a memory optimized, or whether it's a CPU optimized, whatever the criteria is required for the computation power needs to be first of all decided, and then we can go through the rest of the configurations here in the console. So in EC2, we can navigate to the instances menu from the right hand side, and here we can click on the launch instance button, which will actually allow you to select OS, which is AMI. AMI is nothing but an Amazon machine image. So machine image is basically a replica of an OS type. For example, if you need Ubuntu, if you need Windows, if you need Mac OS, so all those kind of OS requirement can be sufficed here. And also few of them are free tier eligible, as you can see here. So you can utilize those free tier up to certain limits. Let me search Ubuntu. So by searching specific OS, you can get it here in the free tier eligible tier as well. If you want to go with Windows OS, then you can search Windows, and you can also have Windows free tier eligible AMIs. If you want to use Mac OS for Apple specific, I am not sure it's going to be free tier eligible or not, but still we can search Mac. And yes, in Mac OS, in Apple specific OS, you are not going to get any free tier eligibility. So let's just stick back with Ubuntu. So the first step is to select the Ubuntu free tier, which we are going to go for the free tier eligible OS or 64-bit. The second criteria here comes with the second step is like instance type. So in the instance type, we are actually going to select the family. Family depends upon your compute memory, CPU, whatever requirement it is. So based on those optimicity, we have to select this T2 family. There are various strategies behind it we have to discuss in depth, but here to go through at a high level, family is something which is subjective with the requirement, and then comes the type. So with each and every type, we have various number of CPUs, various number of memory and instance storages. Okay. So here we are going to go for the free tier eligible, which is for first 12 months, we are going to get it for free up to 750 hours. So we are going to leverage the same thing. Next comes the configuration part. Here comes the networking, security groups, IAM roles, and all those things. And number of instances we want to spin up. As of now, we are going to spin up only one instance. So keeping everything else as a default property, we are going to go further with the add storage. For storage, we are going to attach EBS just like D drive, E drive. We are going to have 8 GB size root volume. We can also add some new volumes if you want. And as per the tags, we can define it like for what usage this instance is going to be created to carry on agree data collection process. And then we can also use environment, like which environment this instance is belonging from. We can enter as test because we are not going to go for any production specific requirement. And for security group, we can have it here as a 22, which is SH, as I said. SLS protocol works at default 20 port number. And here the source can be any because we want to expose our instance to anybody across the world. So we are keeping here as any, which is 0.0.010. Then the last would be to review. So here we can review our instance. This is our Ubuntu OS, which is part of our instance type. T2 micro, which is free tier eligible, and this is our security group having port number 22 whitelisted for any specific IP address. The rest of the instance details are going to be the default one. Storage is 8 GB, and tags we have attached is usage and test environment. By clicking on the launch button, we are going to create here a new key pair. So using this key pair, we can actually SSH into our machine. So I'm entering here agree data collection key pair. So using this key pair, we can actually connect to a server which is hosted in Oregon region. We can download this key pair. This will help us to connect this server. Then we can click create on. Then we can click on create launch instance. So this is the ID instance ID. We can just click on the instance ID. So this is our instance which is under pending state. It will be coming up healthy very soon. Agree collect data instance. So we have run, as you can see, the instance state is under running condition right now. So we can connect to this instance using SSH protocol, and copying this command will help us to actually connect to our EC2 instance. So from the terminal, I can go to the downloads folder. I'm using my Mac machine to connect to this remote server which I have created. So under downloads, there will be the key pair file which we have just downloaded. As you can see here, this is my key pair under the download folder, and here we can use the same command which I copied from the console to connect to that machine, to connect to the server. Permission is denied, so I need to use sudo permissions where I need to enter my system password. It will ask me, are you sure you want to connect it? I will enter yes. Yes, I want to enter it. That's it. This is the IP address. This is my Ubuntu machine, and this is the IP address 172.3.157.173. The same can be confirmed here from the console as well. So this is my agriculture instance, collect data instance. As you can see here, 172.3.151.173. The same IP address is been observed here. So I have successfully connected to my remote machine, and now I can install. We have still 2 to 3 minutes left, so let's install a Apache server on Ubuntu. Okay, we can simply use this tutorial to install it. First of all, we need to update. Okay, it will update the packages. Secondly, we need to install the Apache 2 server. It is reading the package list, and now it will go for the installation. Yes, it is done. Second is installing it. I will enter yes to install all those packages. I need to enter capital Y. Small y will not accept the input. It will consider as no. Now we can adjust the firewall rule. Next part is to allow Apache. Rules are updated. We need to find the status inactive. We need to make it active. We need to enable this firewall first of all. Enable. It will ask me, are you sure? I will enter yes. Firewall is enabled. Now we can check the status. Yes, Apache is there available. Now we can check the status of Apache. You can see service is loaded. is under running condition. Now we can copy the host IP. It is this one. Now what we can do, we can simply use our IP address, instance IP address, which is public. But here in the security group, we need to whitelist the 80 port number, which is used by the web server. So just couple of minutes to go and we are almost done. Edit inbound rules. We need to add rule, custom TCP, to enter 80, and here any is fine. Let's save the rule. I'm entering the IP address. As you can see, this instance has been loaded with Apache 2 default web server. So we have successfully configured the EC2 instance within the time frame, and that's it, guys. And this is how we can utilize the cloud computing. So I hope that gives you a brief introduction about the services which we have on cloud. Let me just post you the IP address. Using this IP, you can reach out to that web server throughout the globe. It is accessible across the globe. One more query here to answer: is AWS offers stable releases OS in case of Linux? Yes, it do. So all the OS are available. All the OS distributions are available in AWS, but some of them are chargeable because the license costing fees are something subjectable to OS. So need to take care of that factor whenever you choose specific OS, because Red Hat Linux servers are quite a bit costly and enterprise level servers are even more costlier. So that's it from my end.
Okay. You done with your presentation now? Yeah.
Yes, I'm done with the presentation. We have gone through most of the topics in AWS infra, and also we can go through some other topics if we have some time.
We do not have time, but in future I am actually expecting your association with us, and because audience are very much interactive with your session, and that is something amazing in your, for particularly for your session. So thank you very much, Dhruv, for taking this lecture. And your session is actually something I believe give idea of what you are giving to the participants and how the participants are perceiving you. So it was really excellent from my side. So we will certainly look forward for your future association in our upcoming events. And so yeah, Mr. Dhruv and Mr. Nikhil and their participants, since time is already approximately 1:30, so we are closing this session here. And in afternoon, we are having our plenary session, and I request all of you to join at 2 p.m. So let's take a lunch break and get back to the plenary session. So that's it from my side, and thank you so much, Mr. Nikhil and Mr. Dhruv, for such an excellent explanation and for your session. It was really, really amazing from my side. Thank you so much.
Dr. Priti, that means us a lot. Thanks. Have a great day. We'll catch up very soon.
Yeah.